This is page 2 of your chapter 8 notes. We are going to find a confidence interval for mu when sigma is unknown. So this is a situation where we're studying acupuncture and pain relief, and we have 15 data values. We are measuring sensory rates, which to me feels like a little bit of a vague word. I'm not exactly sure what sensory rate means, but if we're studying pain relief, then it must be some sort of a measure related to pain relief. We are going to use the sample data to construct a 95% confidence interval for the mean sensory rate for the population. And we assumed that the population is normally distributed. That's important because we only have 15 data values. If we do not have a normal distribution, then we would need more than 30 data values to work with for the central limit theorem to apply. So that's why we stated that the population is assumed to be normally distributed. These are the 15 data values, and we're going to use stat edit and enter the data. So stat edit, and I've actually entered all the data in already. And I just wanted to show you that if you need to clear out any existing data, what you do is you arrow onto L1 or L2, press clear, and then arrow back down, and it will be gone. So I'm going to go ahead and clear out all my lists. It's just weird that you have to go over up, clear, and then go down, and then the data disappears. Up, clear, and back down again. Okay, so now I just have the data that I want in L1, and now that I've done stat edit already, I can go to stat calc one variable stats, and I can reference my list, which is in L1, and frequency list, it had L2 in here, and I pressed clear to get rid of it. We do not have any frequencies. Each of these data values occurred once. And then I just press calculate. And so I have all of the one variable stats available to me. And you can see that X bar is 8.22666 repeating. So I could say 8.23. But I, for some reason, it recorded it as 8.227, which is fine. We know that n equals 15, and I'm going to go ahead and note that degrees of freedom is n minus 1, so it's 14, and we need the degrees of freedom in order to find the value of t. The problem told us to use a confidence level of 0.95, and based on that, alpha must be 0.05. So again, that alpha is 1 minus the confidence level. And S, how do we find S? Well, that's the sample standard deviation, and I find that on my calculator right here. S is 1.672. So I have almost all the ingredients I need. I've got all of these filled out. Now I'm going to go and find T. So it's kind of like Z, but I get it from a table. I'm going to show you all the table method because some calculators have the T distribution and some do not. So in order to find T in our table, which I have linked in the to-do list, and yeah, so let's just remember that we're doing 95% confidence and our degrees of freedom is 14. And I think I have the table attached to your PDF. Oh, I do not. Okay, I'm going to have to bring that over for you. I'll make a separate video on how to read that table. Let me show you how to find t using the calculator for those of you who do have it. You go to second distribution, and then you go to inverse t. So it's a lot like inverse normal, but it's inverse t. And we need to do 1 minus alpha over 2. So we said alpha was 0.05. Alpha over 2 would be 0.025. Let me just get out of here. So what is 1 minus 0.05 divided by 2? Okay, so it's going to be 0.975 right there. And then the degrees of freedom will be 14. So that's what I need to put into my inverse t. Second distribution, inverse t, enter. 0.975 is the area to the left. Degrees of freedom is 14. And I get 2.1447, so I rounded it to 2.145. So there is your t value that you're going to need. Cool. So then we have t times s over root n. So 2.145 is t. S was 1.672 divided by root 15. 2.145 times 1.672 divided by second square root 15. And then arrow out, enter, 0.926. That is my EBM. That is what I'm going to add and subtract from the sample mean. So my sample mean was 8.227, so I'm going to do plus or minus 0.926. 8.227 minus 0.926, and then I can do second entry, and then just change this to a plus, and then I have my two boundary values, so 7.301, 9.153. There is my confidence interval, which means we can estimate with 95% confidence that the population mean sensory rate is between these two values. And I'm going to show you how to do this process again. So we're going to check this using stat tests t interval, enter. This time we have data, so we can just point the calculator to L1. Frequency is 1. I'm going to leave that alone. Each data value has a frequency of 1. Our confidence level is 0.95. And let's just see what it calculates. Wow, it got the exact same result. So that's kind of satisfying. I didn't have to tell it X bar and S because it used the data in L1, and it even looked in L1 and knew this. So it got all of this information just by looking at L1. And then it was able to generate this all by itself. So I might have you do some of these using your calculator, and I might have you do some of these by hand. I will, however, be aware that the TI-83, I'm not sure if it has t-interval in it. I'm remembering that it might not. So for those of you who have a TI-83, you're going to be needing to use the table, and I'll explain how to get a t-value from your table in the next video. Let's just finish this page. A t-interval will be a little wider. I showed you that before. There's a little more uncertainty, and that creates a wider interval. Now here's a new question. Suppose we knew that a confidence interval is 42.5 to 47.5. Could you work backwards to find X bar and the EBM from that information? Sure. In order to find X bar, you take, let's just call this interval A comma B. So X bar would be A plus B divided by 2. I wrote that right there. And that's just like averaging the two endpoints and finding the middle. And then, so if we add them up and divide by 2, we get 45. That sounds good. 45 looks like the middle of that interval. And then EBM is what we add or subtract. So you might be able to just look at it and see that 45 is 2.5 higher and then 2.5 higher. So the other way to do that is to find the EBM by doing B minus A and then dividing by 2. So if I take 47.5 minus 42.5, and then I divide my answer by 2, I get 2.5, and that is the EBM of the interval. So again, does 45 plus or minus 2.5 agree with the confidence interval we were given? Yep, it works. This is the picture that I carry in my head for these situations.